Uh, as you all know that we have discussed in the last classes about the uh, linear system of equations and how the linear system of equation can be reduced in the form of the echelon and the row reduced echelon form and the pivot position and pivot columns. These things we have discussed. And now we are going to discuss about the solution sets of the linear equation. As you all know that there are two different varieties of the linear system. So one is the homogeneous linear system and another one is the non-homogeneous linear system. What is the homogeneous linear system then? The homogeneous linear system means, as you know that if suppose I am having here the equation, as you know, the equation and the parameters say x1, x2, x3, and the right hand side say if I take b, so you will be writing your equation in the form of ax is equal to b. So ax will be equal to b. So this you know. This is the format with which we are studying the linear equation. If the right hand side b, whichever you are observing, if this is equal to 0, if this quantity is equal to 0, then we say that the given system is homogeneous. The homogeneous system is what? The right hand system, whatever you are observing, if it is equal to 0, then we say that the given system is homogeneous. And if it is not equal to 0, then the system is non-homogeneous. Simple. Homogeneous and non-homogeneous. If the right hand side of this equation, if it is equal to 0, then it is a homogeneous. And if it is not equal to 0, then it is non-homogeneous. Okay. Then the next thing, if the homogeneous system we got, then what is the criteria of solution in the homogeneous system? So remember here, I've given the star points. The homogeneous system, Ax is equal to 0, has at least one trivial solution. At least one solution, namely x is equal to 0. That implies, if suppose you are having a system, say x1 plus x2 plus x3 is equal to some 0 and x3 plus x4, sorry, again 2x1 plus 2x2 plus 2x3 is equal to 0 and say 3x1 plus 3x2 plus 3x3 is equal to 0. If something like that you are having a linear system, then this x1 equal to x2 equal to x3 is equal to 0 will be the trivial solution, which is always true. So by substituting this x1, x2, x3 value as 0, you'll be getting the right hand side as equal to 0. That is ax is equal to 0. You will get this. So this implies this x1 equal to x2 equal to x3, which is equal to 0 will be a trivial solution. Means always it is possible. Always it is true. That is the meaning. So remember, homogeneous system will be having at least one solution, namely x is equal to 0. Or we can say it as in terms of vector, if you talk, then the 0 vector in the nth dimension will be always a solution for the homogeneous system. If it is 3 cross 3, then the solution is in R3. If it is 2 cross 2, the solution is in R2 and so on and so forth. Similarly, the zero solution, what I'm talking here, this solution is called as the trivial solution. This solution is called as trivial solution. Trivial means it is always true. Okay. Then for a given equation, a say ax is equal to 0. The important question is whether there exists a non-trivial solution also. I mean, if suppose ax is equal to 0, then x1, x2, x3, or I mean, like how many variables are there? That many variables, if they're equal to 0, then okay, it is satisfying the equation. It's a trivial one. What about the non-trivial solution? Is there possibility that we will get the non-trivial solution also? Yes, the answer is yes. So for Ax is equal to 0, the homogeneous system, we do have a non-trivial solution. That is a non-zero vector x such that which satisfies Ax is equal to 0. So implies that this homogeneous system is having both trivial as well as the non-trivial solution. Okay. Then the homogeneous equation Ax is equal to 0 has a non-trivial solution when, if and only if the equation has some free variables. This free variable concept I will explain you with the example. Okay, so what is this free variable? Then you try to just understand the homogeneous system is if the system of equation is of the form Ax is equal to 0, it is called as homogeneous, and homogeneous system is having a trivial solution. Trivial means x is equal to 0 will be always a solution for the given equation. And with this trivial solution, it also has the non-trivial solution. When it is going to have a non-trivial solution, when it has some free variables, at least one free variable, then it will be having a non-trivial solution. So remember this. Then again, next important concept here is you are having the system called consistent, system called inconsistent, based on the solution only. If a solution, if a system is having a solution, whether it is a single solution or infinitely many solution, if it is having a solution, then we say that the system is consistent. The system is called as consistent if it has at least one solution, minimum one solution, or it may be having the infinitely many solution. Then the system will be called as the consistent system. If the linear system has no solution, then it is called as inconsistent system. Now we are going to discuss the problems on this consistent and inconsistent. So some examples I'll show you on consistent and some examples I'll show you on inconsistent. Again in this consistent I have to show you the examples on existence of one solution and existence of many solution. So let us see the examples now one by one. So now may I know if you have any doubts here, let me know. And moreover, with this again, now at this point, we are in a position to determine that we have three types of linear equation system, which has no solution, which has exactly one solution, and which has infinitely many solutions. So these are the three types of linear equations which we are going to deal with. Either it has to have one solution or many solution or no solution. That's it. Other than that, we have no category here. So now may I know if you have any difficulty here? The non-homogeneous thing I'll take up little later. Okay. When it comes, I'll take it. May I know any difficulty you are having here? Any questions?
No, ma'am.
No, ma'am.
Okay. So now we will go with an example. See, determine if the following system is consistent. So here the question will be like this. Determine if the following system is consistent. So you have to reduce the row operations. If the solution exists, then you have to conclude that yes, the system is consistent. If the solution does not exist, then you have to say that the solution is not consistent. Simple. Okay. And remember here, whenever they ask you whether determine the system is consistent or inconsistent, there is no need of writing x1, x2, x3 value. Just looking at the solutions, you can just give the answer. If you write it also, no problem. Okay, both the things I'm making clear. Now let us start with the solution. We will take the augmented matrix of this problem. Okay, so what we do here now, we'll start with the augmented matrix. Just a moment. Okay. So here, the augmented matrix of this linear system will be 1, minus 2, 1, 0, 0, 2, minus 8, 8, and minus 4, 5, 9, minus 9. Okay, so this is the augmented matrix. Now what I have to do? See here, this is already 0. I have to reduce this matrix in a, echelon and row reduced echelon form so that I'll get the solution. That's the whole idea, okay? So everywhere we'll be using this concept only. So now let us start with the row operation. Now since here I have minus 4, I want to eliminate this. So what I use, R3 changes to R3 plus 4 times of R1. So by doing so, what I get? Say 1 minus 2, 1, 0 as it is. This second row also as it is. The third row will be now minus 4 plus 1 will be 0. 5 minus 8 is minus 3. 9 plus 4 is 13. Minus 9 minus 0, that will be just minus 9. So now I've got this equation. So from the R2 I can take this 2 out. So R2 changes to 1 by 2 times of R2. I'll do, then I'll get the first row as it is. The second row will be 1 minus 4, 4. The third row is as it is. Now again, I want to make this term 0. In order to make this term 0, I'll change R3 changes to R3 plus 3 times of R2 because here I have 1, here I have minus 3. If I multiply this R2 with the 3, then I'll get this term as 0. R3 changes to R3 plus 3 times of R2. If I do this, it is 1 minus 2, 1, 0, 0, 1 minus 4, 4, and this is 0 minus 3 plus 3 is 0, then 13 minus 12 is plus 1, minus 9 plus 12 is 3. Okay, so once we do this, the next stage I think we have to change the R3. R3 changes to, because I have to have the, this R3 changes to R3 plus 3 times of R2. Is that so?
Yes, ma'am.
Yeah. Then what I get? What I'm getting? So this I've got. R3 changes to 3 times of R2. This I'm making 0 and I've got this. The next is what? Simple. Next is I think I have to make this term 0 and I have to make this term 0. So what I'll do, R1 changes to R1 minus R3. By that I'll get this term 0. Correct? Then in order to make this 0, I'll use this R3. So R2 changes to R2 plus 4 times of R3. So this term will become 0. This will be 1 minus 2. This 1 minus 1 will be 0. And 0 minus 3 will be minus 3. Then this 0 minus 0 will be 0. 1 minus 0 is 1. Minus 4 plus 4 is 0. Then 4, this plus 12, that is 16. Then this R3 as it is. Now again, what is remaining? I think this term is remaining. So for, eliminating this term, I'm taking the help of R2. So R1 changes to R1 plus 2 times of R2. I'll do this. It is 1, 0, 0, 29, 0, 1, 0, 16, 0, 0, 1, 3. So from this, step clearly, I'll get x1 from here, x2 from here, and x3 from here. That is x1 is equal to 29, x2 is equal to 16, and x3 is equal to 3. Thus, by the observation, it is clear that x1 is 29, x2 is 16, and x3 is 3. So this implies what? We are having a solution now. So it is unique, of course, it is a unique solution. Therefore, the solution exists, and also the solution which existed here is a unique solution. Then the system is consistent or inconsistent? Yes? Don't sleep.
Consistent, ma'am.
Consistent, ma'am. Consistent.
So the solution is consistent. So therefore, we say that the system has unique solution and the system is consistent. Okay? So please remember, whenever you are solving the system, if you get a solution and that if it is unique, you mention it, and since the solution existed, we say that the given system is consistent. Okay? Then this part.
One term can be 0 also, ma'am.
Sorry?
No, like x1, x2 can be 0 or x3 can be 0.
Yes.
Even
0 is also a value, right? 0 also is a value, right? So it may be 0.
Even negative, ma'am.
Yes. Positive, negative, 0. Anything may be possible. Okay? So this part I'll pick up when I will be taking the non-homogeneous linear system. Okay? Now this example you see. Solve the system. Again, of course, the right hand side is not 0 here. It's a non-homogeneous system. The one which I have solved is also non-homogeneous system. You can see here. This is also non-homogeneous system. Okay? So now we'll solve this example. The augmented matrix is, so this is the augmented matrix, 1 minus 3, 4 minus 4, 3 minus 7, 7 minus 8, minus 4, 6, minus 1, 7. Now, what are the operations we have to carry out? See, R2 changes to R2 minus 3 times of R1 and R3 changes to R3 plus 4 times of R1. So by doing this, I'll be getting this value. You also try to, calculate it. Meanwhile, see, it is the R1 as it is. R2 will be 0, minus 7, minus 3 times of. So it is minus 7 plus 9, that is 2. Then 7 minus 12 is minus 5. Minus 8 plus 12, that is plus 4. Okay, so we'll be getting this R2. Then R3 will be R3 plus 4 times of R1. Minus 4 plus 4 is 0. Then 6 minus 12, that is, 6 minus, what do you get it? Minus 12. This one. This term, right? So 6 minus 12. Yeah, minus 6 you will get. Yeah, minus 6. Then next is 3 and the next is minus 9. Okay. So now from this, what you can take out from R3, I can take this minus 1 by 3 because here it is minus 6, here you're having 3 and here you're having minus 9. So I can take this 3 out. So I'll take minus 1 by 3 out from R3. If I take that, it is 1 minus 3, 4 minus 4, 0, 2 minus 5, 4 and 0, 2, this is 2 and minus 1 and 3. So this is the term I'm getting. Now I can make this 0 with the help of this R2. So I do now R3 changes to R3 minus R2. So by doing that, I'll be getting this value as 0. So this is 1 minus 3, 4 minus 4, 0, 2, minus 5, 4, and 0, 0. This is minus 1, minus of minus plus. So it is plus 4. Then 3 minus 4 is minus 1. Okay. So now I think you have got all these terms are 0. Okay. And what we will do now? We want to make this term 0. For that, what I'll do? I'll multiply this with 4 and this with 5. That is R2 changes to 4 times of R2 plus 5 times of R3. By doing that, I get R1 as it is. R2 will be 0, 8, 0, 11, and the last row as it is, R3. Okay. Then again, for like in order to make this R1, this term 0, I'll take the help of this R3. So R1 changes to R1 minus R3 I'm doing. I'm making this term 0. That is R1 minus R3 will be leading to 1 minus 3 as it is. 4 minus 4 is 0. Minus 4 and minus of minus plus 1 is minus 3 again. Then 0, 8, 0, 11. Then 0, 0, 4 minus 1. So now what we do? Again, I want to make this term 0. Take the help of this R2. So this you multiply with the 8 and this you multiply with 3. You'll be getting this term as 0. So by doing that, I've got this term. That is 8, 0, 0. 080 and 004, and this is my the last column. So now what we do from here, I can get this 8x1. If you want, you can just take this 8 from R1, 8 from R2, and 4 from R3, or you can directly also write. That is 8x1 is equal to 9, and 8x2 is equal to 11, and 4x3 is equal to minus 1. So this will lead to x1 is equal to 9 by 8, x2 is equal to 11 by 8, and x3 is equal to minus 1 by 4. This implies you are having the unique solution. X1, X2, X3 are, like the system is having the unique solution. So if the solution is unique or the solution exists, then what is the system is called as?
Consistent.
Consistent. So therefore the system is consistent. Okay. So this is how you have to conclude it. Now similarly you can see this example. See, solve the system. X1 is equal to x1 minus 3x3 is equal to 8. Try this system, guys, quickly. Now you are able to solve it, right, by using the row transformation. Already I've solved it. Just take this problem and solve it and give me the answer. You can just see the answer when you can see. Don't look at the answer and try it. You do it, and then you can see the answer. So when you are solving the equation, this 0 is equal to 5 by 2 is the short form of nothing but 0 into x1 plus 0 into x2 plus 0 into x3 is equal to 5 by 2. So we don't have x1, x2, x3 such that which satisfies this equation 0 is equal to 5 by 2 after in a triangular form. Obviously, which has built the contradiction. 0 is equal to 5 by 2 is what? It is a contradiction. Therefore, there are no values of x1, x2, x3 that satisfy this equation 1, because this equation 0 is equal to 5 by 2 is never true, correct? So therefore, if this kind of equations are coming into the picture in the linear system, once you do the row operation, then the system has no solution. The system has no solution. If the system has no solution, then the system is inconsistent. So always remember, if you get we have a theorem also of that type. If after reducing the matrix in a row echelon form anyway, then you will be getting a system of the form, say in any of the row, if it is in this way. So 0, 0, 0, B. If this form you are having a row. In this form, if you have any row, then that system is inconsistent. That system has no solution. Because you'll be getting here 0 is equal to what? Some number. 0 is equal to some number means what? The system will be inconsistent.
Inconsistent.
Okay. So now this is one example for the inconsistent system. I'll take some more examples here. I think now this problem is clear, guys. The inconsistent one. So whenever
Yes,
you're
ma'am.
taking the row transformation, you'll be getting one row in this way. That will decide the inconsistent system. Now I'll take one more example here. See, solve the system. Here we'll take the augmented matrix as 1, 4, minus 5. That is the first element is 0. So 0, 1, 4, minus 5. 1, 3, 5, minus 2. And 3, 7, 7, 6. So this is our system of linear equation, which I'm written in the form of augmented matrix. Now I'll change this R1 and R2 because the first term is 0. So interchanging, I'll be getting this term. So this is my R2 now, this is my R1. Now, in order to make this 0, R3 changes to 3 times of R1. Okay, so if I do that, this is 1, the first row as it is, the second row as it is, the third row will be 0, minus 2, minus 9. Correct? Because you have to make this R3 changes to R3 minus 3 times of R1. 7 minus 9, that is minus 2. Then 7 minus 15, that is minus 8. 6 minus of minus plus 6, that is 12. Now from this R3, you can take 2 out. In fact, I'll take minus 1 by 2 out. So R3 changes to minus 1 by 2 times of R3. If I do that, it is 0, the first row as it is, second row as it is, the third row will become 0, 1, this will be 1.
Excuse me, ma'am.
Yeah.
I think it has to be minus 6.
Yes, you're right. You're right. It has to be minus 6. Okay, so R3 changes to R3 minus R2, we will get, and once we get this, I think it's easy now to make this 0 by using this R2, just 2, R3 changes to R3 minus R2. Okay, so what we get, 0 minus 0 will be 0, this is 1 minus 1 is 0, 4 minus 4 is 0, then what is this? This is minus 6, minus 5 will be minus 11. Correct? Sorry, minus 6, minus of minus plus 5, it will be plus 1. Sorry, minus 1. It is not minus 11. Please make this changes. So this has to be minus 1. Again, you have got one row where you will be getting what? 0 is equal to minus 1. Are you observing this? Now, if you write this equation in the form of linear equation, it is x1 plus 3x2 plus 5x3 is equal to minus 2. Then x2 plus 4x3 is equal to minus 5, and this is 0 is equal to minus 1. So if this is the case, then what do we get again? What are you getting? You are getting the contradiction. So which is the contradiction? Thus it has no solution. Therefore the system will be inconsistent. Are you able to follow it? How the
Yes, ma'am.
inconsistent system will looks like? Guys, all of you.
Yes, ma'am.
So only
Yes, ma'am.
only I think Arham is following Chandrasekhar.
Yes.
Yeah. Good. So now everybody has to follow the things. If you are not getting, please let me know. Now solve this system, guys, same way. Let me see whether it is inconsistent or consistent. And give me the solution if it existed. Check this quickly. You take this.
Excuse me, ma'am.
Yes, beta.
Ma'am, if we find the determinant of the matrix and
See, there are, as I told you, there are many methods.
it is equal to 0, then won't we get to know if it's consistent?
See, when you are getting that, we know that that is one of the type of finding the solution, but that is not there for your syllabus. For your syllabus, whatever is there, that we are covering. Understanding? If you do that way, which is not there in your syllabus, you will not be getting the marks. So these are the actually way of solving the problems in different way. So now this is one of the way of solving by using the row echelon form and reduced echelon form. Then you will be having Gauss elimination method. So there is one more method called LU decomposition. There is one more method called Jordan method. So there are many methods which are being possessed in your syllabus. Only we are taking up that methodologies. There are many other methods. As you told, if the determinant is having 0, then we'll not go with the consistency, inconsistency. Even we'll talk about that there also. But here, the consistency and inconsistency will be based on the solution. Okay?
Yes, ma'am.
Okay.
And this is inconsistent.
This is inconsistent.
What are you getting the last one? What you are getting that as 0 or anything?
10, ma'am.
X2.
10.
Yeah. Yeah.
Minus 10.
Is this the way
Minus
you're
10.
getting? Yes? 0 is equal to 5 is the last one?
Yes, ma'am.
Okay.
Is equal to, I'm getting 0 is equal to minus 10.
0 is equal to minus 10. And what about the above the operations you're getting same? And moreover, I'll tell you, if I saw, I mean, like, if I change this R3 by 1 by 5, so I divide this with by 1 by 5, then it is 0 is equal to 1 only. If you take minus 10, divide it by 1 by 10, that's what you will be getting, 0 is equal to 1 only, correct?
Yes, ma'am.
So no problem, because some row operations you might be doing, but finally you should get that is the system is inconsistent. But you should not do some mistakes and you should arrive at the inconsistency that is there. Okay, the row operations you might be using different. Just check your answers. All of you have to get the system as inconsistent. One who has solved this, you can try for this also. This is another example which you can solve. Now tell me, up now we have taken the examples on the consistent and inconsistent. So do we have any questions on this?